Okay, we're live. Right. So, actually, make sure the microphone's on. Yeah, cool. No, that's okay, Ben. Anyway, so we're doing 3 problems here. So for each function, we're going to find X and Y-intercepts, find the asymptotes, vertical and end behavior asymptotes. We're going to do a sign analysis so we know whether the graph should be above the x-axis or below the x-axis. And of course, we're going to take all the information and generate the graph. So these are the 5 things we're going to be asked to do for each function. So we'll start with number 1. Number 1, f of x equals, in this case we'll say x over x squared minus 1. Okay, so part A is find the x and y-intercepts. Now remember what that means. An x-intercept is when y equals 0. A y-intercept is when x equals 0. The y-intercept should be real easy. If you plug in 0 in for x, what would the y-intercept be for this function? 0. 0. Because 0 over negative 1, which is 0. Okay. Now, how do you make a fraction? Because y equals a fraction here. How do you make a fraction equal to 0? What has to happen? What will be the x-intercept for this function? Let's go ahead and say it. Not quite. Y equals 0 when what equals 0? Yeah, what happens when a numerator of a fraction is 0? What happens to the whole fraction? And what does y equal? The whole fraction, right? So in this case, if you set the numerator equal to 0, you still get 0. So when the numerator equals 0, that's when y equals 0. And of course, the numerator is just plain old x. So if you set x equals 0, you get 0. That's right, you got it. But we could have other x-intercepts too. I mean, depending on what's going on up top. Okay, VA is how I'll abbreviate the vertical asymptote. So remember, that's just when you want to set denominator equal to 0. This is after, very important, this is after simplifying, because you could have removable discontinuities if you don't simplify. So what would that be for this one here? Yep. So you have 2, because if you set the bottom equal to 0, x squared will equal 1, and of course x will equal plus or minus 1. And actually, let me end behavior asymptote. What do you think this would be? Y equals y will equal 0. That's because like either horizontal or slant asymptotes. So it's basically how the ends of the graph behave. When x gets really big or really small. Actually, that's what I did right now. Right. Right. Looking at the degrees. Yeah. Exactly. Right. Because no, we're just generalizing. If m is less than n, so and actually let me remove this here. Yeah, if m is less than n, that's y equals 0. Or another way to think about it, it's bottom heavy. That's right, what? Part. Oh, sorry. It is B and C. Thanks. Okay. Now for D, we're going to do a sign chart. So for the sign chart, we need all factors of numerator and denominator. Where are all the factors? X, x minus 1, and x plus 1. So when you do your sign chart, we have 0, 1, and negative 1. And then I'm going to test how many intervals do I have? We have 4 intervals, right? So remember how the sign chart works? The sign chart works by finding all the zeros for your factors, right? For both numerator and denominator, because that's when the sign of the of y will change. So remember, our function is this. So we want to know what happens with f of x. If I plug in negative 2, I'm going to have negative 2 over negative 3 and negative 1. Will that be positive or negative? Yeah, because you have negative, 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 right? So all 3 of these are negative. So, oh, why'd that go away? Okay, so you see why that's negative for f of x? Think about it. If you have 3, if you plug in negative 2, each of these become negative, right? And so you have negative, negative, negative. So how about negative half? That'll be negative, negative, but so that'll be positive. If you plug in half, positive, negative, positive. So y will be negative. If you plug in 2, positive, positive, positive. No, we don't do anything for 0 because we know it's already going to be 0 anyway. Like what happens at negative 1 and 1, those are asymptotes, right? What happens at 0, it's on the x-axis. So armed with all this knowledge, we can now generate our graph. And without having to really make a table, we actually could do a pretty good graph here. Okay, so you have your asymptotes. And then we have our only intercept. Okay. Let's look at the left side. Where should my curve be? Above or below the x-axis on the left side? Below. So I'll just do it like this. And why do I have them go against? Why do I have to go like this? Like why this over here to the left? Because he's got to go against the asymptote, and of course he's got to go against the asymptote over here. Okay, let's look at this graph. Am I going to draw like a smiley face, a frown face, or more like a? So should I be starting up high or down below? Yeah, you want to start up high because of the plus. Because it has to be positive until you get to x equals 0. And then it has to be negative. Do you see why? And then lastly, should be above or below? No. Above. Right? because it's positive after 1. Anything that's greater than 1 for x is going to make y positive. So that's how you generate the graph. And just to be 100% sure, it's going to be non-calc, sorry. So we know we did it right. Right. Okay, let's do another one. So now we can go through this a little more quickly. Now you guys get the idea. Okay, number 2. 2x squared plus 1 over... yeah, I guess we'll do that one. What the heck. 2x squared plus 1 over x squared minus 1. Okay, we'll start with part A. X-intercept, Y-intercept. We'll start with the Y-intercept. That's always easy. What's that going to be? -1. Mm-hmm. Remember, that's when x equals 0. How about the x-intercept? This is a trick question. There's none. Why is there none? Because when you solve it, you get x squared equals -1/2, which would be imaginary. That's for the asymptotes, right? That's for the asymptotes. Well, because think about it, you want y to be 0. How does a fraction become 0 when the numerator is 0? So that's why we only said it for the x-intercepts. So it's never going to cross the x-axis. Yeah. Mm-hmm. Because think about it, that's what makes y 0. So okay, the VA, and of course, part C will be the end behavior asymptote. Okay. What would this be? X equals, yeah, same as before. And the end behavior asymptote would be, yeah, y equals 2. Because in this case, m equals n. Because they're the same degree. Yep, ratio to leading coefficients. Actually, you couldn't use synthetic because the bottom is not a linear expression. You could use long division if you want, and then you would get y equals 2. Y equals 2 plus some weird fraction. When it's top heavy. When it's top heavy. Yep. Okay, and then for D, for the sign chart, our factors. What was that? To figure out whether the graph is above or below the x-axis for each interval. The end behavior asymptote doesn't still tell you how the middle of the graph behaves. Only tells that's why we're doing this. So our factors are those. 2x squared plus 1 can't factor. So we do a sign chart. Now what are the zeros of all these factors? That's it, because the other zero is going to be imaginary. No, you can't do anything for it. Remember, this is for f of x, and f of x equal 2x squared plus 1 over x minus 1, x plus 1. Okay. No, we don't need to because it's not part. Before we had an interval between -1 and 0. We only have 3 intervals now. We only have 3 intervals. We have 2 zeros but 3 intervals. When I say 2 zeros, I mean 2 zeros of our factors. So if I plug in -2, what does this become? No, that's positive. But then in the bottom two become negative. So overall, that's going to be positive, right? Because remember, whenever you square anything, it becomes negative, right? If I plug in 0, that's still positive. The numerators, that's still positive. That's negative and positive, so it's negative. If I plug in 2, positive, 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 so it's positive. Okay? So we generate the graph. So -1, +1. So I kind of spaced up my tick marks, but that's all right. Or y equals 2. And what was our y-intercept again? Yeah, we have no x-intercepts, so this can never touch the x-axis. Okay, so how would I graph the left side first? Yeah, it's got to be right there. Because the left side cannot go below the asymptote. What about the middle? It's like a parabola. It has to be negative the whole time, between -1 and 1 because of the sign chart. And also because it can't touch the x-axis. So we can't have it go. We can't have the arrows go up and down or down and up. And it can't be a smiley face because then it's going to touch the x-axis. And it also has to be negative the whole time. So you have all this evidence here to back up your graph. It could. That could happen. Anyway, so that's how you do the graph. Probably not. Yeah, pretty much just graphing it. So I think you guys get the idea. I'll just stop there.